Hey guys, welcome to RVing with Zeus. My name's Anthony, and today we're going to talk about something that a lot of people don't want to talk about, is batteries for your RV. So, right here there's two different kinds of batteries. You got your 12-volt battery. This is what starts your RV engine. And then you have your deep cycle batteries. These are two 6-volt batteries. When paralleled together becomes 12. And that makes it possible to charge just like a regular 12-volt battery. The difference between the two, cranking power. This one here's got cranking power. Alright. This one here is designed for low voltage usage such as lights. Okay. Lights in the RV. You can use these to start your RV as well. If there is a parallel switch in your RV, you can press that button, and what it does is it parallels these batteries in addition to the 12-volt battery. Should this battery be dead, you can start the RV with this because you have two 6-volt batteries. They're paralleled, so it equals 12. And you'll get the same cranking amps as a regular 12-volt battery. Okay? So what I like to do, this also depends on geographic location. If you're in a warm climate, you don't really have to worry about this too much. You can leave the batteries inside your RV, and then you can attach a charger to a battery. I have this contraption. This is actually a bracket that I use to tie down a exhaust pipe. And what I do is I hang it on the frame of the RV, just like so, and then I plug it in, and I can charge a battery. Or you can set it someplace where it's not going to get wet. So if you're in a warm climate and you are storing your RV, you can technically keep the batteries in there. A lot of people say that you should disconnect the batteries, and technically you really should, because that way you can attach a charging system to the battery, and there's no potential of any kind of short circuit happening inside your RV. So you should disconnect all the cables. So I live in upstate New York, western New York, so we have winters here, and it gets extremely cold. So the problem is that when you leave a battery out in the open, in the elements, okay, for an extended period of time, the charge starts to dissipate. Okay, so now there's a chemical reaction occurring inside these batteries. All right, you have your battery acid, and you have your lead system inside here, and what happens is a chemical reaction between the two, and there's bubbling going on, slow bubbling, which creates a reaction which also equals to heat. Okay, not too much heat. There's venting ports on these batteries so that the excess pressure can release. There's a vent port right here and a vent port right here, and there's one on the side over here too. You really can't see it. These are maintenance batteries. This is a low maintenance battery. This is a maintenance battery. These ports here come out. See, they lift right off, and I can look inside. You have to be really careful. Okay, safety check here. When you work with batteries, you should be wearing goggles, and you should be wearing gloves. I have them right here, ready to go. Okay? So this way you don't have any battery acid in your eye. Okay? So what happens is, in the wintertime, if your battery is exposed to the cold, your battery is going to start to drop in voltage. Okay? This is a 12-volt battery. This is a 6-volt battery. This is a 6-volt battery. But if you parallel the two, there's a parallel cable right here, negative to positive. And if you put a charging system from here to here, it's going to charge both batteries and equal 12. When the battery voltage starts to drop, that chemical reaction starts to dissipate a little bit. And if the battery gets down to a certain voltage, that chemical reaction stops. and that heat is reduced. And what happens if that heat is reduced and it's, let's say, below freezing outside, your liquid inside here is going to start to freeze. And if it starts to freeze, what happens with liquid, any liquid that freezes? It expands. So that liquid is going to expand inside this battery compartment, and it's going to cause a crack. And I had a battery do that a few years ago. It cracked all the way down the length of this box right here. All the battery acid leaked out, and I really didn't pay attention too much to it, but I smelled battery acid. I just thought that was the battery needed to be charged. What I didn't realize, when I plugged this thing in and tried to start it, I wasn't getting anything. And I put my hand on the battery to check something out, and I realized my fingers were getting tingling, and I realized that was battery acid, and there was a crack all the way down the side of the battery. Because the batteries were left outside, the temperature dropped, and the batteries froze and they became useless. These batteries are not cheap, okay? Interstate batteries are expensive. This whole setup right here was probably about $525 altogether. I trust Interstate. These are extreme batteries, which means they take a tolerance. They're designed to be dissipated completely and then recharged. This one here, you want to keep a charge. You really don't want to get it reduced, because if you do, then you won't be able to start your battery. But this battery here can be reduced all the way to nothing and then be recharged again. However, having said that, I want you to keep in mind that you have a charging system that's in your RV. Okay, so you have your electrical system, right? Your shore power that plugs into the RV from a source that's coming from the outside of the RV, like your house or camping system. It's going to connect to a junction box that has a bunch of fuses in it, and in those fuses are junctions and breakers to your deep cycle, your inverter converter, okay, which charges your deep cycle batteries and also charges your house battery, okay? There is a breaker in there. We can get into that later. That if that 3 amp fuse blows, it's not going to charge this battery anymore. And I found that to happen because I found that the battery's dying over the season, and I didn't realize why. Come to find out, there's a breaker inside, or a fuse that blew, and it wasn't charging this battery through the converter. So the converter is charging this, it's charging this, and you, in some cases, in some RVs, you have a monitoring system. You can see how much voltage is in your main batteries and your deep cycle batteries. You can see what the voltage is. You can keep an eye on it. You want to be over 11. You really do. You don't want to be any lower than that. If you see a battery that's like a 10 or 9, that's way too low. You may not have enough torque or cranking amps to start your vehicle, and you're going to have to use your parallel switch and use the deep cycle batteries. So what do? I like to take the batteries out. These things are heavy. Let me tell you, they're not light at all. These are heavy as heck. Okay, I got basically all I did was I grabbed the electrical wiring, I put it onto these eyelets out here, and I can just grab this cable and I can pick up this battery and I can set it inside the compartment. So I take the batteries out. I have a charging system here that's on standby. I have my positive here to the positive and my negative here to the negative of the second battery. These are parallel together. So if I charge it like this, you're going to charge both batteries. If this cable wasn't here, I'd have to move this here without this cable, and I have to charge these batteries individually. So in this case, I'm charging both batteries at once. The next thing that you're going to need is a nice voltmeter or a multimeter. I got this for about 80 bucks at Harbor Freight. It's got a magnet on it, so if I want to, I can attach it to a magnetic system and I can let it hang. Okay. It comes with a nice pouch. So what I do is I put this on the 12 volt DC, and on occasion I will come over here and I'll touch the prong. I'll turn it on just so you're not going to probably be able to see it. I mean, I'll put it like this, but what I'll do is I'll take the prongs and I'll touch either side of the battery. Oops, I got it on the wrong setting here. There we go. All right, so now I'm putting this here, and I'm gonna look at the battery voltage on here, okay? And I'm gonna see if it's at 12. If it's over 12, that means the battery's got a full charge. I don't need to plug this thing in. This one over here, if I plug it in and touch the leads, I got 12.30, which is awesome. Okay. So if, for example, if I put the leads on this battery here and I check the voltage, I'm seeing here 11.25, which is not bad, okay? Which is not bad, 11.25. I probably do want to put it a little bit on the charger. So what I'm going to do is I'm going to plug this thing in. So now my charging volts, I got this set here, 6 amps. And now these batteries are being charged by the meter, okay? I want to keep the charge all through the winter. I have this sitting on a table. You don't want to set it on concrete because the cold of the concrete is going to transfer whatever heat is in the batteries to the concrete, and you're going to kill your battery. So you always want to place it on some kind of wooden system. This is a table. They're sitting flat on the table. It's wooden, so there's no chance of it being drained on the concrete. So now what I can do is I can just go over here and I can check the voltage. So this has jumped up to 13.07. Alright, so now that it's on the charging system, I just want to keep it there. I'll let it sit for a little bit and then I'll unplug it. Great investment because you can check voltages on everything. We'll talk more specifically on this and on tester systems that I have to check like fuses and stuff like that, because you're going to come across situations where a fuse is blown and you can easily check devices like that. I have a tester that checks fuses. So if you touch the leads together, the light will come on the system. It'll tell you if the fuse is good or bad. It is a time saver, especially with the fact that you don't have to take the fuses out. You can test them right there. All right, so now this is pretty much straightforward. I'm getting ready to install these batteries pretty soon. So I'm going to put them in the RV. I'm going to also spray battery terminal protector on these. It must. You know those you have if you go to Advanced Auto, you got these little discs that are red and green. So what I like to do is I like to put them on here and then spray abundant battery terminal liquid on it. It's like a reddish color, and what I do is I saturate that disc. And what that does is prevents any corrosion from starting to occur. You don't want these things to get corroded. The wiring system on these things, these wirings on some of these RVs are very complicated, very expensive to replace. I have a friend of mine who had to replace the entire battery system or charging system from the battery to the deep cycles to the converter. And it cost him $6,000. It's insane because all the wires got corroded while it was in storage. He had it outside and everything got corroded. So you want to make sure that all the cabling is in good shape. You don't want any frayed ends. You want nice wires like this that are coupled at the end and covered. All right. And then what I do is I spray abundant battery terminal protector on these, saturate it, and then every now and then just check to make sure that you're good. If you see that it's drying out, spray some more on it because that prevents any corrosion occurring on these batteries. That stuff can spread like cancer in your RV. There you have it. If you have any questions, drop a comment, subscribe. Have a good day, guys, and travel safe.